Hello again, everybody. Continuing our tutorial of customer complaint comes in and she says she looks at the temperature gauge on the dashboard and she says the gauge is going higher, 230, 240 degrees. And she says, you know what, the car's starting to overheat when it's idling. And she's saying also that both fans are not turning on. As you know, we always need the fans to be turning on to provide us with cold air, to pull in the cold air. Because the engine is running hot, obviously, and the proof of it is that the gauge is going up. Usually the gauge will be high with the air conditioning and idle, but there's about 230, 240 degrees and climbing and climbing. Now, as I said in my previous videos over there, we need the engine coolant temperature sensor to tell us how hot the engine is getting. The key is, remember, we need a 5-volt reference. This is a thermistor, as I went over in other videos, means as it gets hotter, resistance goes down. When resistance goes down, voltage across it goes down. So from 5 volts, it'll descend and go down and down and down when it gets hotter. Now, the key over here is, and this is a very complicated circuit. It doesn't look like it, but it is. This is a circuit for the ages, like we say. It's complicated, and you have to analyze it from many different angles. As we said before in the other one, just to recap very quickly, because I had about 3 videos on this. This is a PCM. This is the computer module. It gives us a ground. It gives it a ground. We need a ground for the relays to be activated, to be magnetized. I put a ground here, I put a ground here. This is what the PCM does for us. When it sees that it is hot with the engine coolant temperature sensor. Quickly, current flows through here when it gets a ground. Then current flows here. This is now toggled in. The switch is toggled in as the pink, you see the pink over here. And then this motor goes in, starts turning. This one, depending on this one, if this is activated, this will be in this position, the pink. If not, it'll stay in this one, and you'll have both coming on. So I figure instead of 12 volts, you'll have probably half, 6 volts across it. When this is working, again, this is in the pink. Now what happens to this one? This goes here, goes right to ground. Right to ground. And what happens? Current now goes here from the ground given by this. Current flows here to toggle this. So now this one goes to ground instead of this one going to this one. Therefore, current goes here and this one is turned on by this toggling. So therefore, either both of these are on from this, or this one is on by itself from the ground, or this one is on by itself. So therefore, let's analyze one more time. Complaints, she says both fans are not turning. Hot. Engine is getting hot, obviously. We have to think from troubleshooting point, what will knock both of these out? Not one. This might work when this one doesn't work. It's like a protection circuit. When this doesn't work, you'll have both of these working through this. But instead of 12 volts, these are like in series. So you can have about 6 volts over here, 6 volts over here. So if you measure at this point over here and this point of the relay, if this is working, you'll measure about 6 volts over here, like I said, black and red. If this is being toggled by this one, you'll get 0 volts because this is now ground. That's how you know this is working and this is working. However, problem is both are not. What will knock both of these out? Let's go step by step by step. And like I said, this is a circuit for the ages. I've been in electronics for 30 years. This is a doozy. Okay, component by component. We're going to go through it. Even though I can tell you one shot, it's either this or this. And we'll see why I come to that conclusion. What would knock both of them out? Well, this fuse is blown, let's say. What would happen? No current here. Even though this sees it hot, it gives it a ground, but no nope, no current here. This is not being turned on. No, this is not toggle. Therefore, if this does not toggle, no current through this. However, this is the sticking point. Just because this has a fuse blown over here, this gives it a ground here. Therefore, current can flow here. This will toggle. Current can flow here. This one will work. Therefore, can't be a fuse. Step by step, let's analyze it. I hope you understood that. This does not work, but this one does work. Yet, the customer complaint is both of them do not work. That's why we're overheating. I'm going to continue with the next video. Like I said, I hope please try to subscribe to my channel, Automotive Schematics by Joseph. I would appreciate it. And again, we're going to analyze it step by step, component by component. This is one for the ages.